Hello everyone, it's Mrs. Davitt here, and today we're going to talk about the interior and exterior angles of polygons. So let's start with interior angles. First, it's important, of course, that we understand the terminology. So let's look at some polygons. And when we're considering what we call the interior angles of a polygon, these are the angles formed between the sides of the shape. So in my triangle, we're talking about these angles. Now, as it turns out, there are patterns for the sum of the interior angles of any polygon. We know what it is for a triangle. The sum of those three angles should be 180 degrees. And I suspect you know what it is for a quadrilateral too. It's 360 degrees. But let's think about why that might be. Well, if I split my quadrilateral into two triangles, all of the angles in those triangles touch the interior angles of the quadrilateral. So two triangles times 180 degrees equals 360 degrees. If we continue with this kind of thinking, splitting our polygons into triangles, a five-sided shape or a pentagon can be split into three triangles where all of those triangles' angles are part of the interior angles of the polygons themselves. So 3 times 180 degrees equals a sum of interior angles of 540 degrees. We can continue splitting shapes like this. If you try to split a six-sided shape, you can split it into four triangles, a seven-sided shape into five, an eight-sided shape into six, and so on. Where, as it turns out, we always have two fewer triangles than the number of sides. So if you need to, you can pause the video and kind of check that process. But you can see here in our six-sided shape, we have 1, 2, 3, 4 triangles. In our seven-sided, 1, 2, 3, 4, 5, and so on. And again, this is with me strategically forming those triangles so that all of the angles of the triangles are touching interior angles of the original polygons. So now, using that pattern where the number of triangles in the shape is 2 less than the number of sides, we can figure out the sum of the interior angles of every single one of these polygons. The six-sided shape would be 4 times 180 degrees. The seven-sided shape, 5 times 180 degrees. The eight-sided shape, 6 times 180 degrees, and so on. And we would get these sums of the angles. Now, if we continue on, we could organize this information in a table, and we could summarize the pattern that we just got this way. The sum of the interior angles of a polygon equals the number of side lengths minus 2, that quantity times 180 degrees. We can also rearrange this to look more simply like the quantity 180 times the quantity n minus 2. Now, if we're dealing with a regular polygon, if it has n sides, it would also have n interior angles. So if we wanted to know the measure of just one interior angle, we could take this formula for the sum of all of the interior angles and divide by n to get the measure of one interior angle. Keep in mind, though, that only works for regular polygons because it assumes that those interior angles are all congruent or equal in measure, which will only happen if it's a regular polygon. So let's take a look at a couple examples. The first example is pretty straightforward. If we're trying to find the sum of the interior angles of a tengon, aka a decagon, we could just use our formula that we just found, 180 times n minus 2, which would be 180 times 10 minus 2, or 180 times 8, or 1,440 degrees. In the second example, you're asked to find the measure of one angle of a regular hexagon. So again, we can use our formula 180 times n minus 2 to find the sum of the angles in a hexagon, but then we know we're finding just one angle, so we'll actually be dividing by n the number of sides. So if I plug in 6, I end up with 180 times 4 all over 6, or 720 divided by 6, or 120 degrees for each individual interior angle in a regular hexagon. So let's think about what we would do if it's not a regular polygon. In my third example, the shape clearly doesn't look like each angle is congruent, and you can tell from some of the ones that are marked that they are not. It is not a regular polygon. However, we can figure out the sum of the angles in this polygon to start. When I count it, this one has 7 sides, so using that formula, 180 times n minus 2, I get 900 degrees for the sum of all 7 interior angles. Now, if I want to find that one angle that's marked, the m minus 9, I'm going to have to figure out a way to solve for m. So think about what it means for the sum of the angles to be 900 degrees. It literally means that we are going to add all of those angles and set it equal to 900 degrees. I'll simplify, solve for m, and then go back to take a look at the angle that I found. So the angle that we want to find, m minus 9, will just be 133 minus 9, or 124 degrees. So now that we've considered interior angles, let's talk about what exterior angles are in polygons. Again, the terminology is important. So here are my polygons. If I want to see what an exterior angle is, what I do is I extend the sides of the polygon and I look at the angles formed outside of the shape between the extended side and the immediate next side. And then we kind of pinwheel around our shape, extend this side, and look at the angle to the immediate next side. Again, there's a pattern for the sum of the exterior angles. Now, it helps to consider the interior angles first. So we're going to work right now under the assumption that all of these are regular polygons. It's a regular triangle, an equilateral triangle, it's a square, and a regular hexagon. So I would know what the interior angle measures are because I know the measures for an equilateral triangle and a square, and we just found the measures for a hexagon. Then, if you notice, the exterior angles form a straight angle with the interior angles that we know, which means that each of those exterior angles is supplementary to the interior angle. That's a really important pattern. Each exterior angle is supplementary to the interior angle. We'll come back to that in an example. So what that means is I can quickly find all of those exterior angles by using those angle pairs. And then the really interesting thing is if I check the sum of the exterior angles, it always equals 360 for any of these polygons. And as it turns out, even if they are not regular polygons, the sum of the exterior angles will still always equal 360 degrees. Now, if they are regular polygons, you'll notice that each exterior angle is congruent to each other, equal in measure, and we can find it by just taking that 360 degrees and dividing again by the number of sides, because the number of exterior angles matches the number of sides. So let's look at a few examples. Now the first two should be easy breezy and super fast. The sum of the exterior angles of a 20gon, 360 degrees. The sum of the exterior angles of a regular heptagon, well, a heptagon has 7 sides, but it doesn't really matter, it's still 360 degrees. One exterior angle of a regular heptagon, now here's where we need to know the number of sides, right? We'll take that 360 degrees and divide by 7 to get approximately 51.43 degrees for one exterior angle in a heptagon. So let's kick it up a notch and see if we can find one exterior angle. If we know that one exterior angle in a regular polygon equals 20 degrees, can we find the number of sides? Well, we know that one exterior angle would be equal to 360 degrees divided by the number of sides. So we can set that equal to 20. And then when we solve, we would get n equals 18. So that would be an 18-sided shape. The last example is a little complex, and be careful. It's giving you one interior angle in a regular polygon. So why do I have this with the exterior angle examples? Well, let's take a look. If I know one interior angle in a regular polygon, I can go back to the interior angle formulas, and I can set that equal to 180 times n minus 2, the sum of the interior angles, divided by n, the number of sides, and that would be equal to 135. Then I can cross multiply, do some maneuvering and solving, and get n equals 8. But there's an easier way. Think about how you could use what we talked about with the exterior angles. Interior and exterior angles are supplementary, which means they add up to 180 degrees. So if the interior angle is 135 degrees, the exterior angle is 45 degrees. Now the formula for solving for n there will be much faster. 360 divided by n is equal to that 45 degrees, and if you solve that, you very quickly get n equals 8. So think about how you can use these relationships between interior angles and exterior angles to help possibly guide you to a quicker or more efficient solution as you're solving some of your examples in the lesson. Thanks so much for joining me. Have a great day.